Today we're going to talk about fractions. With fractions, the first question we ask is what a fraction is. So, what a fraction is the numerical representation of some parts of some whole. And so an example is 1/2, where 1/2 is probably one of the most common fractions we work with in our day-to-day life. Because half a minute, half an hour, half of a cookie, half of a pizza, half a dollar. We use fractions quite often, but we don't realize that we're using fractions as a part of that. And so, what are the components of a fraction? Well, the numerator is the top. The numerator describing how many parts of the overall fraction we're looking at, whereas the denominator, the bottom, describes how many equal parts there are in total. And so 1/2 is saying there's two parts of this total thing. And if we're looking at 1/2, we're only looking at one of those parts. And those parts are equal in size. And so this brings us to math. Well, in math, fractions are actually something that are quite common. And so anytime we're dividing, what we're actually doing is we're multiplying by a fraction. And so 1 divided by 2 is equal to 1 times 1/2. It's the same thing. It's just a different way of writing 1/2. And so this is a rule known in math is just when you divide by a fraction or divide by any number for that matter, all you're doing is you're multiplying by the inverse of the number you're dividing by. And so we'll show a little bit more clearly how we use it with fractions when we're working strictly with fractions here in a second. And so common fractions in our everyday life include pizza. Pizza's one of the common things because it's relatively easy to understand. So first off, we have half a pizza is cut the pizza into two separate slices, and we have 1/2 on this side. It's a half circle, right? Or a half moon, you know. And so 50%, which is equal to 0.5, which is equal to 1/2, are all the different ways of writing 1/2 in the simplest form. And so if we were to take this pizza and let's say we cut this slice in half, well, that gives us 1/4. And that's 25%, or 0.25 and 1/4. And so a quarter of a pizza looks like this, where if we were to cut this pizza up into 4 slices, 4 evenly split slices, each slice would have this size. And then if we were to cut it up into 8 slices, each slice would look like this, where we have an eighth equal to 12.5%, or 0.125, or 0.125. And so you can keep cutting these slices into smaller slices. So cutting this in half again would give us 1/16. Cutting that slice in half again would give us 1/32, and so on and so forth. And so pizza is a really easy way of representing fractions and the different sizes that they represent. Because we know that 2/8, so 2 of these slices, 2 of the 1/8 slices, is equivalent to 1/4 slice. Or so one slice, when we cut it into 4s, is equal to 2 of the slices when we cut it into 8. We also know that 2/4 is going to give us half, or 4/8 will give us half. Because what is 4 divided by 8? Well, 4 is just half of 8, and so we can simplify it down to 1/2. And we'll show that methodology here in a minute. When we talk about fractions in our everyday life, it may not always include pizza. And so oftentimes, if we're shopping, we're looking for deals. And so when we're looking for deals, we often look at 50% off or any sort of percentage off. We're looking for those deals that are giving us some percentage or some fraction off the price. And then this also kind of comes into the same ideology where we're dealing with money. Money, at least in the American money system, we have dollars and then we have change, where change is representing some fraction of the dollar. And so we have a penny, which is 1/100th of a dollar. We have a dime, which is 1/10th of a dollar. A nickel, which is 1/20th of a dollar because it's 5 cents. A quarter, which is 25 cents. And so that's kind of where the 1/4 a quarter comes from, why the quarter's named. And then there's the half dollar, which is 50 cents. If we were to also look at the idea of driving around, at this point, many of us have at least ridden in a vehicle, if not driven one, and we all are familiar with the fuel gauge, or if you're driving an electric vehicle, your battery, how much battery you have left. And so that would be represented in terms of some fraction of your total range. And so if you fill up your gas car with a full tank, and you drive quite a while, you'll see that gauge start going down. So what this gauge's reading is 5/6 of a full tank. And so that is a gauge representing your total fuel compared to how much fuel you have. And we know we don't like it when it gets down to E, because that means we have to go buy more gas. And then the final thing that we often use is measuring. And so measuring is used when we're building things or if we're cooking. You often are using fractions. So if you're baking a cake, you're using X amount of flour, which could be 6.5 cups of flour. Or you're using a ruler or a tape measure, which is really good for learning fractions and how to compare them in terms of using them in math. And so this kind of brings us into the idea of using fractions, and the idea of that there are fractions that are equivalent, as well as representing them in decimal form. And so here I have a graph that shows all the way up to sixths. And so representing this, if we were to take just one part of each of these values, 1/2 is going to be 0.5. So 1/2 is the largest fraction we can get with just whole numbers included in the fraction. So 1 and 2 being the smallest numbers that result in a fraction of 1/2, or 0.5 represented in decimal form. It's the largest fraction you can get with whole numbers in the fraction. And you could get larger numbers, but only if you have decimals or even fractions inside of a fraction. That's a little complicated that we can discuss further on. But we know that 1/2 is going to be our greatest fraction. And then as we increase the size of the denominator, the bottom number, the fractions get smaller, because as the number that you're dividing by gets bigger, the amount of times it goes into the number on top gets smaller and smaller. And so we know that 1/2, 1/3, 1/4, 1/5, and 1/6, they're never going to equal one another, and this graph decays. It goes down as we go up. And so if we go to the next step, however, we start to see that some of the values start equaling each other. And so in the case of halves, there's only two numbers we can get. And so when we have 1/2, it's 0.5. When we have 2 halves, we end up getting just 1, because 2 divided by 2 is 1. But when we're looking at thirds, we get 2 divided by 3. And so that gives us a 0.6 repeated. And so this 0.6666 keeps on going forever. And then we realize that 2/4 is equivalent to 1/2, because we can take 2 and take it and put it in both the numbers, both the numerator and the denominator, and that gives us 1 and 2, because 2 goes into 2 one time and 2 goes into 4 two times. And we can see that with this bar, these two values are equal. And then we also have 0.4, which is equal to 2 divided by 5. We see that that isn't equivalent to anything so far, or as a matter of fact, it won't equal anything on this particular graph. And then we have our sixths, where we have 2/6, which again, we can take 2 and put it into both numbers. And so 2 goes into 2 one time, 2 goes into 6 three times. And so that gives us 1/3. Much like 1/3 over here, we get 0.3333, 0.3333. And that's repeated, it goes on forever. But let's go to 3. So if we have three parts of a number, we end up getting 1 if we're dealing with thirds. But we have 0.75 or 3/4 when we're dealing with fourths, 0.6 when we're dealing with 3/5, and 0.5, which again is equal to 1/2 when we're working with 3/6, because 3 into 3 is 1 and 3 into 6 is 2. And so let's go to the fourth. And so for 4, we end up getting 1. And so 4 over 4 is 1. So when we're dealing with fourths or quarters, when we have 4 quarters, we have $1. Or if we have 4 fourths of a cup, we have 1 full cup. And then 4/5 is 0.8, and 4/6 is 0.6666, which again is 2/3, which we can show again if we take 2, which is a common factor of 4 and 6, and take it in and put 2 into 4 and 2 into 6 and see how much we can get. So if we go to 5, we end up getting that the fifths ends up equaling 1, which is because it's 5 over 5, or 5 divided by 5, and that's just 1, because 5 goes into 5 one time. But for sixths, we get 0.8333, which is repeated. The threes are repeated. It keeps on going forever. And then for the last one, we have 6. So it takes each one of these halves, thirds, fourths, fifth, and sixth. It takes the number of the denominator, takes that many parts to get to 1. That's relatively straightforward to understand. If we want the whole of something, we have to have all the parts. And so if the numerator is describing the amount of parts we're looking at, and the denominator is describing the amount of total parts we have, then it's just a matter of collecting all those parts, looking at all of them to give us the whole, right? And so when we're using fractions in math, there's a few different operations that we have to take into account. So multiplication and division are actually counterintuitively the most straightforward when working with fractions. And so when we're multiplying, it's straightforward because it's the top times the top, and the bottom times the bottom gives us our new fraction. So A times C and B times D is going to give us our answer. Whereas when we divide, it's much like the example I showed earlier, we actually have to flip the second term, the term that we're dividing by. So we read left to right, and so A over B divided by C over D is actually equal to A over B times D over C. And that gives us AD divided by BC, or A times D divided by B times C. Now, these two operations are relatively straightforward. It's the tricky part is remembering the divided by. We have to flip that second term, the term that we're dividing by. However, when it comes to addition and subtraction, there's something that is a common mistake when learning fractions that we want to highlight and avoid. So when we're taking a over b plus or minus c over d, it's not a plus minus c divided by b plus minus d. That is not how we add fractions. For an example, you would be taking 1/2 plus 1/3 does not give me 2/5. It's because we know that 2/5, if we were to go back, 2/5 actually is less than 1/2. And so if we add 1/2 and 1/3, we expect to get a larger value. We expect to be here, 5/6. But if we were to add them together, we would get 2/5. And that's not right. So the correct way of adding them together is we have to find a common denominator. And so that's what this expression here shows. So in order to add a over b plus or minus c over d, so adding or subtracting, we have to have a common denominator. And so what that means is we need to take the first term and multiply it by a special version of 1. So d over d is the denominator of the second term in both the numerator and the denominator. So if we have the same term over itself, we get 1. So this is just a fancy way of writing 1 times a over b. But what this does is it forces the bottom, the denominator, to take a different value while also changing the numerator. And so that gives us AD over BD. And then we plus minus the CD times the B over B. And so we need to take the denominator from the first term and apply it to the second term. And so what that gives us is BC over BD. And then when we add or subtract them together, is AD plus or minus BC divided by BD. And so with this in mind, the most complicated way of dealing with fractions is actually the addition and subtraction of them, which is so counterintuitive to the way we learned math, because we learn math starting with addition, then subtraction, and then we work into multiplication and division, and then we keep going. Whereas with fractions, the easiest way is to start with multiplication, then go to division, and then go to addition and subtraction, because addition and subtraction actually includes multiplication. And so when dealing with fractions, there's something that we want to be aware of. We don't like 0 in the denominator, because 0 is a really weird number with math. If we divide by 0, what is actually happening is that number is becoming an undefined number. It becomes infinity because 0 is so small. Dividing by 0 is actually impossible, and it breaks math. And so we can't do it. Whereas 0 divided by a number, it's just how many times that number can go into 0. But that's just 0, because 0 is a number that doesn't have value. And so when we divide into it, we just get 0. It's a lot like multiplying by 0, we get 0. It's 0 of nothing. Like when you have 0 of something, it's 0. But if you're dividing by 0, so you're dividing by nothing, then you would get everything, which makes no sense. It doesn't work with math. But when we do multiply with fractions that have a common term, so a divided by b times b divided by c, what actually happens here is that a times b divided by b times c, the b actually cancels out. And so since they're the same term, they equal 1. Right? So b over b gives me 1, and so what I'm left with is 1 times a over c, which is just a over c. And so when we're working with fractions that have common terms, we can cancel those common terms out. So let us look at some practice problems we have kind of laid out for you. So I implore you to pause the video and attempt to solve these problems before we get to the solution section. I did leave the general form the problems should take in your problem solving, and I also left some hints as to the ways you can go about them. And so going forward, we can discuss the solutions. And so when I have 2 times 3 times 1 over 6, or not 2 times 3, when I have 2 over 3 times 1 over 6, that is 2/3 times 1/6, what I end up getting is 2 times 1 divided by 3 times 6. That gives me 2 over 18. And since I can take 2 and put them into both of these numbers, I can get 1 divided by 9. And so the way that works is I know 2 goes into 2 one time, and I know 2 goes into 18 9 times. And so I simplified this fraction by changing it to this. If both numbers are even, we can simplify. If they have a common factor, we can also simplify. If we end up resulting with a prime number in either the numerator or the denominator, a prime in which a prime being a number we cannot divide into other than 1 and itself, we can't simplify the fraction anymore. And so we have 2/5, both prime numbers, they cannot be simplified, divided by 3/7. Again, both prime numbers, this fraction cannot be simplified. And so we say that this is equal to 2/5 with times the second fraction flipped, 7/3, which is equal to 2 times 7 divided by 5 times 3, which gives me 14/15. Now 14 is an even number, 15 is a composite odd number, meaning it has factors, but since this number doesn't have common factors, the factors of 14 being 1, 2, 7, and 14, the factors of 15 being 1, 3, 5, and 15, they don't have common factors, so we can't simplify this any further. And so this is more an example of what this is not supposed to equal, a reminder. And then we have our 1/5 plus our 2 plus or minus our 2/7. Now if we took the plus case for this answer over here, we have 7 over 7 times 1 over 5 plus or minus 2/7 times 5 over 5. And let's take the plus case where we end up getting 7 times 1 plus 2 times 5, which is 10, which is 17, divided by 7 times 5, which is 35. So we end up getting 17/35. 17 is a prime number, which doesn't allow us to simplify this any further. And again, we have our 52 divided by 0, which is just infinity, or an undefined number, because we can't divide by 0. It breaks math. 0 divided by 34 is just 0. And that's because it's 0 parts of 34 total parts. We just get 0. And then our final one, 3/5 times 5/8 gives us 3 times 5 divided by 5 times 8, which is equal to 3 times 5 crossed out over 5 crossed out times 8, because the 5 over 5 cancel to 1, resulting us in 3 divided by 8. And so this brings us into a practice word problem. A practice word problem of the likes of you and your friends going out for pizza. And so you go out for pizza with a small group of friends, Jack, Sam, and Peter. The group of you buy a pizza that is traditionally cut into 8 slices. So Peter, having eaten a late lunch, only eats 1 slice, while the rest of the group, including you, has 2 slices each. So first, you want to answer how many slices in total were eaten, and then for part B, we look at what fraction of the pizza was eaten by each individual. Then C, how many slices are left over. And then for part D is if you had eaten an extra slice, redo parts B and C with that change accounted for. And so we want to write the answers in the form of the fraction, the number of slices compared to the total number of slices. And so pause here if you want to attempt to solve this problem by yourself, and then move on to the solution. And so for the solution, for part A, we're looking at everyone who ate a slice. And so everyone who eats a slice adds up the amount of slices that they eat. And so we show that 1 divided by 8. So Peter ate 1 slice out of the 8 total slices, and then everyone else ate 2 slices. So we're adding 1 plus 2 plus 2 plus 2, which gives us 7 out of the total of 8 slices. So the bottom number doesn't change because it's a common denominator, but the numerator, the top, does. And so we add up the top to give us the total amount of parts that had been eaten. And then for part B, it's asking us to identify how many slices each of them, everyone ate. And so for Peter, it was 1/8. And so this is more along the lines of just taking part A and splitting it up and saying who ate what, how much, and then it also allows us to show how much of the total pizza that Sam, Jack, and you ate, which is 2/8 each, which we can also simplify down to 1/4. So it gives us a chance to show fraction simplification. And then for part C, we have 1 out of 8 slices left, and that's because we know that there was 7 out of 8 slices eaten, meaning that there's only 8 minus 7 left over, which is 1. And then for part D, when you eat an extra slice, so that changes the amount of slices you ate to 3/8, where Sam and Jack each eat 1/4, and then Peter still had 1/8. And so the total amount of slices that we eat changes to 8 out of 8, because we would add all the numbers up. 1 plus 1, we would add all the numbers up. 1 plus 2 plus 2 plus 3 gives us 8. And then we would have 0 slices left over. And then, so this kind of starts to bring us into the idea of what if, in this particular case, what if we had more than one whole, more than one thing we're looking at? What if we looked at more pizzas? Well, that's when mixed and improper fractions come into play. And so this is a general form of what a mixed fraction is and how we get the mixed fraction into the improper fraction form, where the improper fraction to the mixed fraction form is a little bit more complicated, as it requires some division and some remainder. So if you remember if you recall, when you were taught division, you divide a number and then you're left with some remainder. If you remember your remainder notation of division, then this is not that dissimilar to you. So for mixed fractions to improper fractions, it's a relatively simple calculation where we take A, which is the total number of wholes we have, times the C, which is the number of slices each whole is cut into. So if we're working with pizza, and say it was 8 slices apiece and we had 5 pizzas, this would end up being 5 times 8, 5 times 8, which is 40, and then let's say that there were 3 slices of pizza in an empty box. And so this would be 40 plus 3 divided by 8. And that would give us 43 over 8. So 43 total slices divided by 8 slices, which represents one whole pizza. Where A over C, and so this is a little bit more complicated. So C goes into a lowercase a amount of times, and then so A times C is going to be that amount of times that C goes into capital A. But we still have this B term left over, and so B actually has to equal the the big A term, minus the A minus C. Or conversely, A is equal to B plus A times C, like we have written over here. So it's kind of backwards implementation of taking the mixed to improper to get improper into mixed. And so you take C, the lowercase c, take it into A however many times you can to get a whole number result. And then however much your remainder is what your B is. And so for a few examples, we have 3 halves, which is equal to 1 and 1/2. And so we would take, in order to get this into 1 and 1/2, we know that 2 goes into 3 one time, but we have 1 left over. Or, if we're going the opposite direction, 1 times 2 is 2, 2 plus 1 is 3, gives us 3 halves. And again, we can do this example with 13/4. So 4 goes into 13 3 times. We know that it goes up to 12. And so 4 times 3 gives me 12, but 13 minus 12 is 1. And so I have 1 left over. And so using that same ideology, just backwards, 3 times 4 is 12, plus 1 gives me A, or 13 in this case. And lastly, for our last final example, for a large number of wholes, let's say 5 into 132, or 132 divided by 5. So I know that 5 goes into 130 26 times. But there's going to be 2 left over, and so it'd be 26 and 2/5. Now, if I were to convert this into an improper, it's 26 times 5 plus 2. That's 130 plus 2 divided by 5. 132 over 5. And so we can practice this with some of our practice problems here. And so we want to convert the following into the opposite form. And so 32/5 is equal to what? 16/4 is equal to what? 55/10 and 71/2 all equal to what? So we're converting these improper fractions into mixed fractions. And then we want to convert these mixed fractions into improper fractions. And so you want to pause here and try and solve these before looking at the solutions. And so the solutions follow as this. So 32 over 5 gives me 6 and 2/5, because I know 5 goes into 30 6 times with 2 left over. So 6 times 5 gives me 30. 30 plus 2 is 32. 32 divided by 5. The fraction denominator stays the same, but the number in the numerator changes to reflect how many total pizzas we end up having. For a number that evenly divides into the numerator, so 16 divided by 4, writing this as a mixed fraction doesn't make entire sense, mainly because we have 0 over 4 in our fraction. That's just representing 0. So this would be 4 and 0/4, which is just 4, because 0/4 is 0. 4 and 0 is just 4. We're not multiplying this number by the fraction. And that's an important distinction. Mixed fractions are not multiplication. It's 4 total pizzas with 0 slices of a 4-sliced pizza. That's how we would read this. That means there's only 4 total pizzas. And then looking at 55 tenths, we get 5 and 5 tenths, which we know 5 goes into 5, and 5 also goes into 10, so we can simplify this into 5 and 1 half. And so we would have an equal amount of pizza if we had 5 out of 10 slices with 5 pizzas, or 1 out of 2 slices with 5 pizzas. And so those two values are the same. And then our last one, 71 halves, gives us 35 and 1 half. So 2 times 35 is 70. 70 plus 1 is 71. 71 divided by 2. That denominator doesn't change. And so we know that we can prove our mixed to improper or improper to mixed by utilizing the multiplication and division rules that we've shown. And so this is converting the mixed fractions into improper. And so this one is a little bit more complicated, or no, it's not more complicated. So this is the mixed fractions into the improper fractions, which is actually simpler. And because it's all it really is 5 times 2 plus 1 gives me 11, because 5 times 2 is 10, plus 1 is 11. 11 divided by 2, because the denominator doesn't change. 10 times 4 is 40. 40 plus 3 is 43. 43 over 4, because the denominator doesn't change. 3 times 1/3, or not 3 times 1/3. 3 and 1/3 is 3 times 3, which is 9. 9 plus 1 is 10. 10 divided by 3 is 10/3. We can't simplify it. Something I want to note is that 5 and 1 halves over here is equal to 11 over 2, which is, over here, we got 55 tenths is equal to 5 and 1 halves. So there's two different ways of writing. There's actually way more ways of writing 11 over 2, as in this case, because I know that 5 goes into 10 2 times and 5 goes into 55 2 times. I could rewrite this as 11 over 2. And then back to this one, we have 15 and 2/7 is equal to 107 over 7. 107 divided by 7. 7 is a prime number, meaning we can't simplify this any further unless the numerator was divisible by 7. But we know that 107 is not divisible by 7, because 7 doesn't go into 107. It goes into 105, but not 107. And so, continuing on, let's look at a practice word problem in this case. So, you and your group of friends, Jack, Sam, and Peter, order 3 pizzas instead of 1 this time, cut into 8 slices each from the same pizza place as before. Write the improper fraction of how many total slices there are. And then for part B, we have the case that you and your friends eat 2/5 of the total amount of pizza. How much pizza was eaten and how much is left in both an improper form and mixed fraction form? And so the two results should add up to 3, because you started off with 3 pizzas, and so you're looking at how much of the pizza you and your friends ate, which is 2/5 of the total amount of pizza, and then the 3/5 should be the amount of pizza left. But we're wanting the answer in terms of how much pizza there is. And so part C is, if you and your friends were to evenly split the pizzas amongst yourselves, how many slices would each of you get in the form of a fraction of total slices for an individual pizza? And so pause here and try and solve this problem before continuing on. So the solution to this word problem being With starting with part A, is we know that 3 pizzas cut into 8 slices. We have 3 and 0/8. Well, in order to get the total amount of slices, we perform this operation here. So we have 3 and 0/8. We want 3 times 8, which is 24. 24 plus 0 gives us 24 divided by 8. So that's the improper fraction of the total amount of slices. Moving on to part B, we know that there's 2 different ways to actually approach this one. The way that I show first is using the improper fraction, because improper fractions are most commonly used in math, whereas mixed fractions are used more common in real life circumstances. Improper fractions are used in math because they're easier to work with mathematically. And so we get 24 divided by 8 times 2 divided by 5, which is equal to 48, because that's 24 times 2, divided by 8 times 5, which is 40, which we can simplify down to 6 over 5, because 8 goes into 48 6 times, 8 goes into 45 times, and that's how we would simplify this. And then converting 6 over 5 into a mixed fraction gives us 1 1/5 of the pizza being eaten. But we also can take 3 pizzas, because that was the total amount of pizzas. So this is simplifying the 24 divided by 8, simplifying that fraction and multiplying it by 2 over 5. And what that gives us is just 3 times 2, because this is 3 divided by 1, technically. Because if we were to divide both of these numbers by 8, 8 into 8 is 1, 24 divided by 8 is 3, so we get 3 over 1 times 2 over 5. That gives us 3 times 2 over 1 times 5, which is just 5. And that gives us 6 over 5. And that's how much of the pizza that was eaten. And we can do the same exact thing for how much pizza is left over, where now the difference in this case is how much pizza was left over, which is 3/5 of the total amount of pizza, because we ate 2/5 of the pizza and we have 3/5 left over. We know that 2/5 plus 3/5 is equal to 5/5, and that is equal to 1. And so that tells us that the sum of these two numbers, these two fractions, improper and mixed fractions, should add up to the total value of 3. And so we get 24 times 3, which is 72, 8 times 5, which is 40, which we can simplify down to 9 over 5, because 8 goes into 72 9 times, 8 goes into 45 times, and then converting this to a mixed fraction gives us 1 4/5 leftover pizza, where again we can rewrite it in terms of starting with the total 3 pizzas times the 3/5 left over gives us 9/5 of a pizza left, which is 1 4/5 of a pizza left. So going on to part C, we see that if we're trying to split up the pizza, 24 slices out of the 8 slices for each pizza, if we're trying to evenly split it amongst us 4, or you 4, including your group of friends, you have 24 divided by 8 divided by 4. Now we have to use the trick in which we flip the term that we're dividing by, giving us 24/8 times 1/4. And so this results in either 24 32nds, or since I know that 4 goes into 24, I can just divide 24 by 4, giving me 6 divided by 8. And since both of these numbers are even, I know that I can take 2 and put them into both. And I get 3 from the top and 4 from the bottom. So you and your friends get 6 slices out of the 8 slices each for a pizza. So 6 out of 8 slices of each pizza. Or you each have 3/4 of a pizza. So 6 slices out of 8 total slices, or 3/4 of an entire pizza to yourselves. And this kind of brings us into the summary of what we've gone over. So, what did we go over? Well, we went over what a fraction is, right? Which is it's some portion of equal parts of something. Doesn't matter what it is, but pizza is an easy thing that we often use. And then we went over the fraction operations. So multiplication is the most straightforward of all the operations. Remember, it's just top times top divided by bottom times bottom gives us our result. Division is the second most straightforward. The only thing that complicates it is that we need to flip the second term, or the term that we are dividing by. So that term needs to be flipped in order to then multiply, which was the straightforward operation. The complicated one is the addition or subtraction. And this is the most complicated, mainly due to the fact of we need to find common denominators. And common denominators are taking the denominator of the other term and finding a common term. So the easiest way to do it is to take the two denominators from the two terms and multiplying them together. It's not always the smallest number, but it is the guaranteed way of getting it to work. And then we went over the idea that a zero in a numerator is okay for a fraction, but a zero in the denominator is not, because it breaks math, and we actively avoid this because the answer becomes undefined or infinity. Mixed and improper fractions are two ways of writing fractions when there is more than one item we are dividing into equal parts. So mixed fractions are often used in measurements when building or cooking or stuff like that, real world stuff. Where improper fractions are used in higher maths or just math in general, as they're simpler to write and work with within complicated equations. I hope that this tutorial was helpful for those of you who are struggling with understanding fractions in math and in real life. We went over a lot of the generic cases of how do you manipulate them in math, as well as discussing real life circumstances of using fractions. And so I hope that you learned something and will move forward with a different view of fractions.